All right, so I'm going to be going over the stories you guys wrote and also kind of be talking about what the graphs should have looked like if the stories were accurate. All right, so graph number 1. A mechanic is 5 miles from his house and walks to his car a mile away towards his house and gets there in 3 minutes. So we know he's starting out 5 miles away, so that's correct. And then it says he walks to his car a mile away towards his house and gets there in 3 minutes. So we know he's 5 miles from his house, so he's walking towards his house, so that should tell us he's kind of walking downward. All right, and so it's 1 mile and 3 minutes. So 1 mile, 3 minutes. Okay, so that checks out. He gets to his car and fixes it with the tools he grabbed, and it takes 4 minutes. So the 4 minutes, he's standing there and he's just working on his car, so that's no motion. He fixes his car and drives the remaining 4 miles to his house in 2 minutes. So here he goes, okay, and he drives the remaining 4 miles to his house, and he does that in 2 minutes, okay? So this should have worked out. Your graph should have been similar to this. I don't see any problems, well, maybe except for like if you didn't realize his house was this way. You might have drawn the graph going up instead of down, but the graph should have looked like this. All right, the second graph is here. It says, Orange, the goldfish, swims at a constant rate of 2 meters per second, and at 8 meters, he got hooked for 2 seconds. All right, so he swims at a constant rate of 2 meters per second. Okay, and apparently he does this for 8 meters total, so that would be 4 seconds. So here he goes. He's swimming, all right, and there he stops because it's 2 meters per second. So then he gets hooked for 2 seconds. So here he is, and he gets hooked for 2 seconds, so he's not moving for 2 seconds. Then he decides that he wants to go back home. So he swims at a constant speed back home, and he does 4 meters in 2 seconds. So here he goes. He's swimming back towards home, and he swims 4 meters, and he does that in 2 seconds. He gets hooked again for 2 seconds. Okay, so there he is. He gets hooked again. Then for a meter per second, he goes 4 meters in 4 seconds back to get food. So he's changing directions. So he goes 4 meters in 4 seconds back to go look for some more food. Then he decides, no, I'm going to get hooked again, but he doesn't. And then he goes back home and doesn't get any food at a constant speed of 4 meters per second for 8 meters. So here he goes. All right, so he's going 4 meters per second, and he goes a total of 8 meters, so that brings him down here. So that would have taken 2 seconds total. So, your graph, if you were really, really paying attention and following the story, your graph should have looked just like this graph. It may have been just a little bit confusing, especially when we start talking about the direction changes, and then like the last time where it says he decides he's going to get hooked, but then he doesn't. That may have been confusing for some people, but if you really concentrated on what the graph said, or excuse me, what the story said, then you should have been able to graph this pretty accurately. All right, the next graph, so graph number 3. All right, it says Billy is 12 meters away from his house, and he's drinking water for 4 seconds. So here he is. He's 12 meters away from his house, and there he is drinking some water for 4 seconds. And then he starts jogging for 12 meters for 6 seconds. So here he goes. He's jogging. Okay, he's jogging 12 meters, and he does that for 6 seconds. So then Billy has asthma, so he takes a 10-second break. So here he is taking a break. Okay, so no motion. And he uses his inhaler during that 10 seconds. Then it says he starts jogging back towards home for 10 seconds and stops 4 meters away from his house. Now, this would require us to assume that the house is at 0 meters away. So 0 meters over here. So that may have been confusing for some people, but you should know that the line's going down and that he's jogging this direction for 10 seconds. Now, the length of your line may have been a little bit sketchy there. So then it says a neighbor was passing by, so he stopped to say hi for 4 seconds. So right here, there he is saying hi for 4 seconds. So up until this point right here, your graph should have looked exactly like this. And then here, this is where it gets a little bit confusing because maybe you were confused on how long this line should be. But then the end, you should have definitely ended with a horizontal line because there was no motion. He was talking to his neighbor. All right. Oh, no. Sorry, I just dropped something. All right, next graph. So graph number 4. This one says, a group of friends traveled 5 hours to a nice hotel 3 kilometers away. So 3 kilometers away, 5 hours. Boom, that part checks out. And then they decide to take a 3-hour rest. So here they are, boom, they take a 3-hour rest. After they woke up, they traveled 4 hours to a campsite that was 9 kilometers away. So here they are traveling 9 kilometers away, and they do that in 4 hours. They stayed for 2 hours and realized they left all their luggage. All right, so here they are. They stayed for that 2 hours. Okay, so 2 hours, they're just staying there. They're not moving. All right, but then they realized they left all their luggage, so they traveled 6 hours to get home, which was 12 kilometers from the campsite, which took 6 hours. Okay, so here was their original campsite. Okay, we know home is 12 kilometers away, and they had to drive back home to get their luggage, and they did this in 6 hours, so that should have been a straight line going down just like that. So, your graph should have looked just like this graph because you had all the information that you needed in order to properly graph it. Okay, next graph. A man takes his dog to the park to play fetch. He told his dog to sit for 3 seconds. Then the man threw the ball 8 meters and the dog ran to get it, and it takes 8 seconds. Okay, so a lot of information happening there, but we know that he tells his dog to sit for 3 seconds. Okay, so here he is telling the dog to sit for 3 seconds, so no motion. Then the man threw the ball 8 meters and the dog ran to get it, and it took 8 seconds. So here's 8 meters in 8 seconds. Then he stops for 5 seconds to breathe, and the man threw the ball again. All right, so there they are stopping to breathe. Then the man throws the ball again, and it goes 6 meters, and the dog takes 2 seconds to get it. Okay, so here it's going 6 meters and 2 seconds right there. Hold on, I lost my place. Okay, so it also says that the dog went the way they were before. So that's how you know that the line slopes down. Because it says he threw the ball, again, 6 meters away. Then it took the dog 2 seconds to sprint towards the ball, towards the way they were before. Okay, so that kind of vaguely indicates that they turned around. So the dog stops again to give the ball to the man for 2 seconds. Okay, so here's the dog stopping, giving the ball to the man for 2 seconds. And the man threw it 2 meters, and it took 5 seconds to walk there. Okay, so then he throws it 2 meters, and it took 5 seconds to walk there. Okay, so they're still going in that same direction. Then it says the man laid on the ground with the dog for 4 seconds. Okay, and then the man called, "Let's go, Chubbs." All right, so here the man is laying on the ground with the dog. So this story, like when you break it down, it's accurate, but it's a little bit confusing, especially with the direction that the way the line should be going. Like right here, this gets a little confusing about which way the dog actually went. So you may have gotten all of this part correct, and then your line may have gone up like this, just because that part, like I said, was a little bit confusing. All right, graph number 6. So starting at 3 meters, a basic girl sprints 1.5 meters downward to the Starbucks in 2 seconds. So starting 3 meters, okay, the girl sprints 1.5 meters down towards the Starbucks, and it takes her 2 seconds. Then she takes a break for 2 seconds, okay. Then she sprints another meter downwards in 1 second, okay. Then she takes a break for another 2 seconds, okay. Then once again, from being exhausted, then she turns around and sprints back 2.5 meters and does this in 2.5 seconds. So then she turns back around and then sprints that 2.5 meters in 2.5 seconds. And then she gets home and she decided not to get Starbucks. So you should have been able to recreate this graph accurately based on the information provided in the story. Okay, graph number 7. Okay, Bobby walks at a constant speed of 1 kilometer in 0.2 hours. Okay, so there he is, 1 kilometer in 0.2 hours. So we go into the corner store. Then he chilled with his friends while drinking an icy for 0.2 hours. So here he is drinking the icy for 0.2 hours. Okay, he's just chilling, so there's no movement. He walks back to his girlfriend's house, Reese, for 0.75 kilometers for 0.2 hours. So there they go, walking back 0.75 kilometers, and that takes 0.2 hours. After that, he takes his girlfriend to the mall, accelerating at a constant speed of 1 kilometer in 0.4 hours. So they use the word accelerating here, trying to get you to understand that they change direction. All right, so they accelerate back up this way at a constant speed of 1 kilometer in 0.4 hours. So up to this point, everything is pretty easy to understand. But then you may have not realized that they were using the word accelerate to actually change the direction there. You may have just associated it with a change in the velocity, which could be also a change in speed. So hopefully your graph ended up looking like this one. The only other thing that I could see happening here is that it went down so that you just kept making your line go down instead of going back up. But this stuff should have been right on your graph. All right, and then the last graph, number 8. The Flash runs 10 meters in 1 second. Okay, so there he goes. Then he stops at the store and got food in 1 second. Okay, so he did that. Then he goes up to the Super Bowl, 30 meters in 3 seconds. So now he's going an additional 30 meters and does that in 3 seconds. And then he goes back home from 40 to 0 in 1 second. So this is telling you that home is 0, like at the 0 mark right down here. So here he goes from 40 to home, and he does that in 1 second. So you should have been able to recreate this graph as well. Okay, so pretty accurately. All right, so hopefully you understand if you're one of the groups that had a couple issues with your story. Hopefully you understand why the issues were what they were, and you know how to fix them because your test is coming up, and you're actually going to be getting a study guide today, so make sure you fill that out and then study it. Your test date, originally it was supposed to be Monday, but it got moved to Tuesday, so please make sure you are studying before that test. Also, the study guide that you're getting today, make sure you have it filled out and you bring it to class on Monday because we will be talking about it. Also, tomorrow is your benchmark. Okay, do not freak out about it. Okay, just study your anchor charts and do the best that you possibly can on it. Okay, but other than that, just make sure you have your study guide filled out for Monday, and I'll see you guys then.